So lesson 3.3 is talking about increasing and decreasing functions, and then something called the first derivative test, which is how we find those maximums and minimums. Okay, so the first thing that we know is this. If the derivative is greater than 0 or positive, if the derivative is positive, then the function is increasing. If the derivative is less than 0 or negative, then the function is decreasing. If the derivative equals 0, then the function is constant. That's where our maximums and minimums are happening. So our critical numbers are happening there, partially from there. So to find intervals of increasing and decreasing, here's some steps for that. So if I'm looking at a graph, so let me show you some pictures here real quick of what I'm talking about. So if I'm looking at a graph like this, this function right here is decreasing, it's constant here, and it's increasing there. So what you can do is find, like, this would be a critical point, this would be a critical point, these would be endpoints. So what I could do is say, okay, what's happening in this interval? Somewhere inside there, is the derivative positive or negative? And then here, find a point somewhere inside here and decide if it is positive or negative in the derivative. So is it slope positive or negative? Same thing here. Look for some value in this interval and ask, is the slope or the derivative positive or negative? If it's positive, this is going up. If it's negative, this is going down, so increasing and decreasing. If it's equal to 0, that's just a constant. So it's straight out. Okay, so hopefully that'll help a little bit. So in this first problem, it says find the open intervals on which that function right there is increasing or decreasing. So the first thing I'm going to do is find the derivative. And then I'm going to find those critical numbers. So right here, here's my steps on what to do here. Number 1, find critical numbers. So my first step is to do the derivative. All right, so the derivative of this would be 3x squared minus multiply by 2. That's going to cancel this denominator, so that makes that just 3x to the first. Then I need to find the critical numbers. So 3x squared minus 3x is my derivative, and I want to know, when is that 0? So I'm going to factor out a 3x. So I get x minus 1. So that means, according to this one, x equals 0, and with this one, x equals 1. So those are my critical numbers. So what I'm going to do is make a table. In that table, the first thing I'm going to do is do my intervals. Then I'm going to do some test values. I'm going to call that TV for test values. Then I'm going to find what is the sign of my derivative, so f prime of x. And then I'm going to come up with some type of a conclusion here. Is it increasing or decreasing? Okay, so my first interval, this did not give me an interval to look at, which means I'm going all the way from negative infinity all the way up to positive infinity. So if I'm stopping at 0 and 1 to see what's happening, my intervals are going to go from negative infinity up to 0, then from 0 up to 1, then from 1 up to infinity. And that's the only ones I have to check. So here's my critical numbers, 0 and 1, and I'm checking to see what's happening on this side of that, what's happening in between, and what's happening on that side of it. Okay, so my test values, I need to pick something in this interval, some x value in that interval. So that was, again, where I'm saying what's happening in this section, right? So if this is 0, then maybe I check negative 1 over here and see what's happening. So my test value in that case, I'm going to say it's negative 1. This one I need a test value that's between 0 and 1, which means I have to pick a fraction, so I'm just going to pick 1/2. 1 and above, I'm going to say this one is 2. So you can pick any value. So I could have picked 50 in this one, but then I have to plug 50 in, and I don't want to do that. So, okay, so now, let me bring this down a little bit so you've got a little more space. I now have to check and see what is happening to the derivative at that point. So I need to go into the derivative here, which was this, and plug these values in. Okay, so if I plug in a -1 right here, -1 squared is 1 times 3 is 3. And then a -3 times a -1 is a +3. So I get +6, or really it's just positive. I don't care about the number. I just want to know what the sign of that is. So if it's positive, according to this statement up here, if my derivative is positive, my function is increasing. So in this interval, this is an increasing function. All right, if I plug in 1/2 right here, 1/2 squared is going to be 1/4 times 3. So I'm going to multiply those. So 3 times 1/4, and then I'm going to subtract 3 times 1/2. Well, that's going to end up negative because this value is going to be bigger than this one. So this is going to be negative, which gives me a decreasing function right there. If I plug 2 in, 2 times 2 is 4 times 3, and then I'm going to subtract a 3 times a 2. This is bigger, so this is going to be positive or increasing. So they wanted me to identify the open intervals on which that is true. When is it increasing and when is it decreasing? So I would say it is increasing on this interval right here, so from -infinity up to 0, and from 1 up to infinity. It is decreasing then from 0 to 1. That's the interval. Now, I wrote mine in interval notation. You could have written it as, I think the book says, from -infinity up to 0, and from 1 up to infinity. They write it like that. I prefer this interval notation, but that's up to you. Okay. The first derivative test I will talk about real quickly. So the first derivative test tells me that if something is changing, if my derivative is changing from negative to positive, so that means it's decreasing and then increasing, then that means right here at this point C, we have a minimum value because it went down and then it went back up. So here, positive to negative means it's increasing, positive slope, and then negative slope means it's decreasing. So at that point, that would be a maximum value. If it has the same sign on both sides, so maybe it's increasing and then it's increasing again, but this right here was maybe some type of a critical point. This is called monotonic. So there's no maximum or minimum that's given. This is just called monotonic. Sometimes they will say strictly monotonic. Okay, so the ones we're really looking for are these two scenarios. So in the next video, I will do 3 examples of that.